All right, guys, let's go ahead and finish off this review. Okay. Let's see here. All right, so that's what this is asking me for number 16, find all the local extrema, that's maxes and mins, inflection points, show all number lines in analysis, okay? So check it out, right? Y prime is 3x squared minus 6x minus 9. If I set that equal to 0, I can factor out a 3, and I get x minus 3 and x plus 1. Okay? So, when I solve that, x is positive 3 and negative 1. Just so you guys know, these are called my critical numbers or critical points. All right? I make a sign line graph for y prime. Okay, and I'm going to do test points on the sign line graph, and I'm going to plug it into here, right? So if I pick like negative 2, for example, negative 2 minus 3 is negative, negative 2 minus 1 is negative, negative times the negative is positive. If I plug in 0, 0 minus 3 is negative, 0 plus 1 is positive, so that's negative. When I plug in 4, 4 minus 3 is positive, 4 plus 1 is positive, so that's positive. So I get increasing, decreasing, increasing, okay? So let me write this information up for this one. So I am increasing on the interval negative infinity to negative 1, 3 to infinity. I'm decreasing on the interval negative 1 to 3. I have a relative max at negative 1 something, and I have a relative min at 3 something. Now, I don't know what these y coordinates are right now. I can figure them out by plugging into here. Okay, so if it asks, sometimes it'll just say, what is the x value of the relative max, and that's fine. If it wants you to actually find the point, you would plug it in. Like here, if I plugged in negative 1, okay, let's see, I get negative 1, negative 1 squared, minus 3 plus 9 plus 7. So I get 12. And if I plugged in 3, right, I would get 27 minus 27 minus 27 plus 7. So I get negative 20. All right, and that you get by going back to the original. Okay? All right, sweet. Now let's do my second derivative. So from here, I take a derivative. I get 6x minus 6. All right, if I set that equal to 0, I mean, you can factor out a 6 if you want. You certainly don't have to, but I get x equals 1. You guys, this is called a possible inflection point. And it's a possible inflection point because we don't actually know if it's an inflection point until we test the concavity. So and I'm testing the concavity into here, okay, or that other one, that's fine. So I go, all right, number less than 1, how about 0? 6 times negative is negative. And then a number bigger than 1, how about 2? 6 times a positive is positive. So this goes concave down, concave up. All right? So if I write up my summary where I say increasing, decreasing, concave up, concave down, relative max, relative min, okay? For my information for this, it is concave up. You guys, it's late and it's been a long day. Concave up and down are not relative max and min. It goes concave up, concave down, inflection point. Okay, so sorry about that. So it's 1 to infinity, negative infinity 1, and I have an inflection point at 1 something. Again, how do I figure out what that something is? So I go back up here and I plug it into the original problem. And if I plug in 1, I get 1 minus 3 minus 9 plus 7, which is 8 minus 12, negative 4. Okay, and that's like my summary. All right. Okay. So let me get this next one here. Okay, so the next question for part B, I guess this was like 16A. This is 16B. I have 3x to the 5th minus 5x to the 3rd. Okay, and I want to find, again, all my information. So step 1, first derivative. That gives me 15x to the 4th minus 15x squared. If I factor out a 15x squared, and I'm going to go ahead and keep factoring this. That factors to x plus 1, x minus 1. I get 0, negative 1, and 1 as my critical numbers. I'm going to go ahead and put that on a graph for y prime. Okay? Now, let's see. Negative 1, 0, 1. I am going to test them right into there. Okay, so something less than negative 1, like negative 2. Well, a negative 2 squared is positive. Negative 2 plus 1 is negative, and negative 2 minus 1 is negative. So positive times a negative is positive. Okay, negative a half. If I square it, it's still positive. And then it's negative a half plus 1 is positive, negative half minus 1 is negative. Okay, positive a half is positive, positive, negative. Yeah, so that's still negative. And then 2 is positive, positive, positive. Okay? So you guys, this one, it didn't alternate around the 0, so it's okay. It went 0, and then it goes decreasing, decreasing. It probably flattens out at that point, increasing. All right? So I write it like this. It's increasing negative infinity to negative 1, 1 to infinity. It's decreasing negative 1 to 1. I have a relative max at negative 1 something and a relative min at 1 something. Okay? If I want to find these y coordinates, like if it asks me for what point does it have a relative max, I need to get the x and the y coordinates. So I come back up into here and I figure it out. Okay, negative 1 to the 5th is negative 1, so that's negative 3, and negative 1 to the 3rd is negative. So negative 3 plus 5, so that's 2. If I plug in 1, it's 3 minus 5. Okay? All right, nice. Now I'm going to go to my second derivative. From here is 60x to the 3rd minus 30x. And for this, I'm going to go ahead and factor out a 30x. This is not as fun as I would like it to be. I mean, that's okay, but this doesn't really factor great because 2 is not a perfect square. So I know that this is going to be 0 from that part. And if I were to solve this part, you guys, let me just run over here and solve it real quick. So 2x squared is going to equal 1. X squared is a half. X is plus or minus square root of a half. Okay, so that's like ugly. But anyways, I have plus or minus square root of a half. Okay. Negative square root 1/2, positive square root 1/2. I mean, I would want to have a calculator on this or something. When I go to plug these in, I mean, let's say I plug in a very huge negative number, like negative 100. That's going to be negative. That's going to be positive. So I plug in a very tiny negative number, like negative 1 over 100. That's going to be negative. And that's going to be negative. So I plug in a very tiny number there, like 1 over 100. That's going to be positive, negative. If I plug in a number like 100, that's going to be positive, positive. Okay? So my concavity goes like this. Up, down, up, down. All right? And so I would write it up like this. I am concave up on the interval negative square root of a half to 0 and square root of a half to infinity. I am concave down on the interval negative infinity to negative square root of a half. Let's see. 0 to square root of a half. and my inflection points are negative square root of a half something and square root of a half something. And I would get these by going into my original, and I am not going to do that because you need a calculator for it. Okay? Anyways, everybody feel okay about that so far? All right, let's see here. All righty, let's see here. Okay, for number 17, it says, all right, we're given this equation. Now, this is with x's and y's, you guys, so I'm going to have to use like some implicit differentiation. We need to find the first derivative, second derivative, equation of a tangent line to approximate, and then blah, blah, blah. Okay, so let's go ahead and find our derivatives first. Let's see here. And at the point 1, -2. Okay, so let me find the first and the second derivative. We'll do that first, right? So you guys, this is implicit, like we said. And implicit goes, okay, 2x. This is going to be a product rule. The derivative of the first is 1 times the second. The first is x times dy dx derivative of the second. And then the derivative of y is 1 dy dx equals 0. Remember the way that we do this. Anything with a dy dx stays on this side. Anything without a dy dx, I subtract to the other side. So that's negative 2x minus y. I factor out a dy dx to get x plus 1. And when I divide over the x plus 1, I get negative 2x minus y over x plus 1. All right. When I plug in the point, x is 1, y is negative 2. X was 1, y was negative 2. Cool. Okay, I get negative 2 minus negative 2, so I get 0 over 2, which is 0. All right? Okay, now I'm going to do my second derivative. Let's see if I still have these answers open. I do. Let's go. All right. Just want to make sure I don't make a mistake before I move on. All right, perfect. Okay, you guys, my second derivative, I got to do a quotient rule here. A quotient rule with implicit, which is like, but that's okay. All right. Derivative of the top. That's going to be negative 2 minus dy dx times the bottom minus the top, negative 2 minus y. And then the derivative of the bottom, the derivative of x is just 1, all over the bottom squared. Now, what I'm going to plug into here is I'm going to plug in my point. X is 1, y is negative 2, but dy dx is 0 because I found that out on my last problem. Okay? So it's actually not too bad to figure this out, right? It's negative 2 minus 0 times 1 plus 1. This is negative 2 minus negative 2 times 1 over 1 plus 1 squared. So that's negative 2 times, let's see here. Negative 2 times 2 minus 0 times 1 over 2 squared. So that gives me negative 4 over 4, which is negative 1 for my second derivative. Okay? All right. Next part is the tangent line approximation. Y minus y1 equals mx minus x1. Remember, we're going all the way back up here. That's my point. That's my y1 and my x1. Okay, and so it's like y minus negative 2 and x minus 1. And what's the derivative? Well, I found that right here. My derivative was 0. So it's y plus 2 equals 0x minus 1. So y equals negative 2 is the equation of the tangent line. All right? So it doesn't matter if I'm approximating a tangent line at 0.9. Like if I go into here to approximate this tangent line, it's just going to be y plus 2 equals 0 times 0.9 minus 1. Well, that's still equal to 0, and that approximates it at negative 2. It's not exact, it's an approximation, but it's at negative 2. All right? Now, it wants to know if this is an overestimate or an underestimate. Let's think about what's happening at this point, okay? So, at the point 1, negative 2, the first derivative is 0. The second derivative is negative. All right. The first derivative being 0 means it's a relative max or a relative min. All right. So I know that this is a relative extrema, one or the other. But the second derivative being negative means it's concave down. So this is actually a relative max. Okay. Now, if I were to do a tangent line approximation on this relative max, because of the concavity, right, this point is going to be an overestimation because f of x is concave down at the point 1, negative 2. All right, so that's going to be an overestimation. Does the curve have a relative max, min, or neither? We just said that it has a relative max because it's concave down. Okay. Sweet. So hopefully that makes sense. All right, guys. There's a couple of quick questions we want to go through real fast here. Find the maximum minimum points on the graph of. Oof, this looks kind of crazy. All right. What number was this? 18. Okay. All right. And does it say just maximum and min, not absolute or anything? Okay. So maxes and mins, you guys, are when we want to check the critical points. All right. So check it out. Let me go ahead and take the derivative of this. This is going to give me 18x. This is going to give me 8y dy dx. That's going to give me 54. That's going to give me 8 dy dx. Derivative of 49 is 0 equals 0. Remember, we keep the dy dx's on the same side, move the other stuff without a dy dx over to the other side. So I have 8y dy dx plus 8 dy dx is negative 18x plus 54. And then if I factor out a dy dx, I get negative 18x plus 54. And then I divide that over 8y plus 8. So that's my derivative, okay? Okay, now at this point, we know we have relative maxes and mins when the derivative equals 0. And so really, I can just look at where the top is 0, okay? So if I get negative 18x plus 54 is 0, that equals negative 54, and x is 3. Now, you got to be careful because it does say find the points. And you guys notice it like underlined that. Find the maximum minimum points. The reason it underlined that is because I got to go back to the beginning and I've got to also like find the y coordinates. Okay, so I'm going to say this. Let x equal 3. 9 times 3 squared, that's 81. 4 plus 4y squared. And then minus 54 times 3 is 162. Plus 8y plus 49 is 0. So I have 4y squared plus 8y. And then 81 minus 162 plus 49 is 32. Negative 32. If I factor this, guys, I end up getting y plus 4y minus 2. So y is negative 4 positive 2. So there's actually 2 points. 3, 4. Or sorry, 3, 2 is my relative max. 3, negative 4 is my relative min. I went ahead and graphed this so you could kind of see, right? It's my absolute max and relative max, right? And then that's also my relative min and absolute min, okay? All right, nice. Let's see. Okay, this is good. Okay, so 19, we kind of did a question like this in class, but it was really tricky. So let's try this one. Find A and B. So the graph of ax squared plus bx plus 3 has a relative min at 2, 1. Okay, now, I'm going to look at this and say, okay, this is like a single point. This gives me one piece of information. This actually gives me two pieces of information, okay? What it tells me is that a relative min is where the first derivative is 0. So it tells me that the first derivative at 2 is 0. That's what makes it a relative min. Now, how do we always get the y-coordinate? By plugging it into the original. So the original, if I plug in 2, I should get 1. So this tells me two different things, not just one thing, okay? I'm going to start with the derivative part. Okay, so coming from here, the derivative is 2ax plus b. And what this is saying, because I know it's a relative min, is that if I plug in 2, I should get 0. So I have 4a plus b is 0. That's equation number 1. All right, that's equation number 1. Now, y double prime. Nope, not y double prime. What am I doing? I don't have any information about the second derivative. Regular y, right? Regular y is ax squared plus bx plus 3. And what this tells me is if I plug in 2, I should get 1. So a times 2 squared plus b times 2 plus 3 is 1. So 4a plus 2b. I'm going to go ahead and subtract this 3 over. Gives me negative 2. All right. Now, what I have here, guys, is called a system of equations. You can solve by substitution or elimination. Okay, substitution would be if I, for example, solved that for b and then plugged it in there. Elimination is the one that I like a little bit better. Let me show you guys elimination. I basically set these up like 4a plus b is 0. 4a plus 2b is negative 2. In order to get the a's to cancel out, I'm going to go ahead and multiply this bottom part by a negative. So that's negative, negative, positive. And when I put these together, a's cancel out, right? And so I end up getting b minus 2b. Negative b equals 2, so b is negative 2. Okay? Then I can go back to either equation. Let's say I go back to that one. And 4a plus b is 0. So 4a is 2, so a is 1/2. Okay? And so I can just kind of solve this system at the end. Okay. All right, let's see here. Number 20 is a really good calculator question. So let's kind of go over that. F prime of x equals ln x plus 1, x plus 2 minus cosine 0.3x squared plus 5. Oof. Whew, F double prime of x. See, they make them, when it's a calculator question, you guys, they make these like absolutely insane. 1 over x plus 1 minus 1 over x plus 2 plus 0.6x sine of 0.3x squared plus 5. Use a calculator to find the following in the domain negative 1 to 4. So we're only looking between negative 1 to 4. Okay, we're going to look for f increasing, local max and min, and we just need the x values, and points of inflection. Okay, now what you need to know is, like, basically, you guys, the definitions of these things. We know that, you got to know definitions. F is increasing when F prime is positive. Okay? We know that F's increasing when F prime is positive. We know that there's a local max when F prime changes positive to negative, because it goes like that, right? We know there's a local min when F prime changes negative to positive. So let's go ahead and look at those. First, I'm going to put this equation in my calculator. All right, guys, I went ahead and plugged that in here. I could go ahead and do just like a Zoom 6, probably. That's my standard graphing window. Ooh, that's crazy. Something pretty insane is happening over here, right? Like an asymptote or whatever. Now, really, it only asked me about the domain from what? It was like -1 to 4, I believe. Let's see here. Negative. Yeah, I believe it was -1 to 4. So really, if I just want to like not get totally distracted by all this stuff, I can move that -1 to 4. These numbers weren't that big. I'm going to put that in between like -4 and 4. I think that'll give me a good window. Aha, very nice, very nice. Okay, F is increasing when F prime is positive. Now check it out, guys. Do you see that? Ooh, I was going to see if I could use my drawing tool over here, but that's okay. Let's get back over here. It's positive right here on this section. So if I can calculate that root, that 0, okay, left, right, enter. Okay, that 0 is at 3.198, all right? So I can actually answer my first question. And so my first question is, where is F increasing? So F prime is positive. It started at 3.198 up to 4. So that's where F is increasing. That's the answer to part A. Now, local max or min, first of all, I find critical points where F is equal to 0. And if you guys look at this, that's my only critical point. Now, is that a max or a min? Well, think about it. If I had been making a sine line graph, okay, let's see here. For this like local max min, that's the only time where the derivative equaled 0. And the derivative to the left of it was negative, because these are all negative numbers. The derivative to the right of it was positive. So if the left is negative and the right is positive, we are going decreasing, increasing. So that is a relative min at 3.198. Okay, and it just said I need to put at x equals, because it just said to find the x coordinate. Okay, now for points of inflection, I'm going to go back over here. I'm going to go here, and I'm going to type in what it gave me for y2. All right, so let me go ahead and turn that one off. And let me type this one in. Okay, so I turned off y1, I turned on y2. This was the second derivative on that same interval. Where is the second derivative hitting the axis? Well, it's like a little hard to tell, but let's see if I can find an intersect point here. Left, I'll just go like way up there because I know that's definitely above. And then to the right, let's see where it drops below the axis. If it drops below the axis, oh, come on. Never. Yes. Error, no sign change. So that means that this actually has, now I think I typed this in wrong, guys. Hold on one second. I did type this in wrong. Gosh darn it. You guys, I typed 0.06 instead of 0.6. So frustrating. The tiniest little things. This has a bunch of sign changes, actually. So what I would then do is I would go calculate my 0 on each of these, okay? So I'd go over here. I would go left, right, guess. And that's my first inflection point when x is negative 0.089. And then I go calculate my next 0, which is over here. Hopefully you guys put this video on 2 times speed for this part. Ugh, I want to put myself on 2 times speed. Okay, here we go. And I got 1.949, I guess, if you round. And then calculate my last zero. All right? Little teeny tiny bad boy at the end there. Boom. Boom, boom. Okay, and I got 3.865. Because it's where the second derivative equals 0 and changes sign. So those were my points of inflection. All right? Okay, let me see if these last questions we can probably do on here. Let's see. All right. This is a velocity time graph. So the first thing you got to do is identify what kind of graph you're looking at. Whoops, sorry about that. Okay, this is a velocity time graph. Find the acceleration at 5 seconds. Here's 5 seconds. You guys, acceleration is the derivative of the velocity, so it's the slope. And this goes down 3, 4, 5, 6 over 2. So down 3 over 1, so it's negative 3. I need to put feet per second squared. Find the speed at time 6. Okay, guys, speed is absolute value of velocity. At time 6, the velocity is at negative 3, because that's just the coordinate point on there. So the speed is 3 feet per second. When is the object moving right? Okay, look. This is a sine line graph of velocity, which is the derivative of position. We're going from 0 to 7, and it only changes at 5. And the derivative to the left of 5, this is all positive. The velocity is above the axis. Derivative over here is all negative. It's below the axis. And since I'm looking at the derivative, that's increasing, decreasing. Okay? So the object is moving to the right from 5 seconds to 7 seconds. All right? Sorry, 0 to 5, right or positive. 0 seconds to 5 seconds. Okay, now velocity increasing has to do with the second derivative. And the second derivative is also on a sine line graph from 0 to 7. But you know, the second derivative is the slope of the first derivative. So it's 0 from 2 to 4. So from 2 to 4, it's just 0 all the way through there. It's, okay, so before that, it's coming up, it's increasing, and then it's 0 for a long time. And then it's decreasing down to the 6, and then it's increasing. So it says, is the velocity increasing? And the velocity is going to be increasing here and here. So that's going to be 0 to 2 and 6 to 7. All right. I'm just going to write like this, 0 to 2, 6 to 7 seconds. Speed is in, when is the speed increasing? Okay. Speed is increasing. Now, this is like a little bit of a tricky question. We think we did this in our 1 day of physics, so we got to review this. But basically, speed is increasing when either velocity and acceleration are both positive, or velocity and acceleration are both negative. That's how this works. So the speed is increasing 0 to 2 because they're both positive. Okay. And then 4 to 6, 5 to 7, 5 to 6 is where that overlaps because they're both negative. All right. And then where is the object furthest to the right? Well, it's just asking you about the max, and the max is at time 5. These are tricky. You guys just think about things like way different. So I know that's kind of like a tricky one. All right. Okay. Let's look at, we can do this. 27 and 28. Speed round these bad boys. Okay. For 27. Velocity is 3t squared minus 27. And I can go ahead and make a sine line graph for that. Okay, and so I'm going to get t equals -3 and 3. All right, if I plug into here, I get -4, that's negative, that's positive, positive. Okay, so it just goes. All right, second derivative, acceleration is going to be 6t, and that equals 0 at time 0. And I know that to the left of it, it's negative, to the right, it's positive, so that's concave down, concave up. All right, what is it actually asking me? When is the velocity increasing, right? Velocity is increasing if the acceleration is positive, because you're getting faster. So velocity is increasing 0 to infinity, okay? When is the speed increasing? So once again, speed increases when velocity and acceleration are both positive, velocity and acceleration are both negative. So -3 to 0, because these are both negative, and then 3 to infinity because they're both positive. Okay? Yeah, that's good. All right. Displacement, you guys. Displacement means where it starts, where it finishes. So from 0 to 4. Okay, so from at time 0, I'm plugging that in here. At time 0, I get 50. I'm plugging 4 into here. At time 4, I get 64 minus 27 times 4 plus 50. At time 4, I get 6. The displacement is -44. But now it's going to say what's the total distance. And if you guys remember, we talked about this. With total distance, we got to count everywhere it turns around. So it starts at 0, it turns around at 3, because that's what's happening here. All right, it's going one way and then it goes the other way. And then it ends at 4. Well, this is 50, this is 6, and at 3, if I plug that in, that's going to be -4. All right, so look. From here to here, from 50 to -4, it went a total of 54. From here to here, it went 10. So 64 is the total distance. All right, so that's how I can find total distance. That's going to be 64. Okay, and last question. Oof, let's see. A triangular line is being mowed, so the base of the triangle is decreasing. The base of the triangular lawn, okay. The base of triangle is decreasing, and the altitude, so let's call that altitude and base. So dB dt is -2 feet per minute. The altitude is always 3 times the base. Okay, well that's better. So we'll just call altitude 3b. How is the area changing when the base is 100 feet? All right. Well, okay, the area of this triangle is 1/2 base times height. So I'm going to go ahead and call the area 3/2 b squared. Now, if I take dA dt, this is going to give me 3b dB dt. Okay, so that equals 3. It says when the base is 100, and dB dt was -2, so that's going to equal -600, and it's going to be feet squared per minute. All right, so it's being mowed at a rate of -600 feet squared per minute. That was a rough one, guys. If you stuck through that whole video, props to you. Okay, good job.